We're just setting up our environment because we're going to do a little bit of demonstration for you guys, which is why it's taken Tom a minute here to set things up. So I'll play the MC before we beat you guys down with slides and kind of set up the stage of what we're going to talk about here today. So the session that we put together, and first of all, let me introduce myself. My name is Merlin Glynn. I'm a product manager for PKS, which hopefully you guys have had some indoctrination to PKS, and raise your hands if you are a PKS user. Awesome. It's nice to see that flowing out in the crowd. So any questions that are PKS related, please feel free to throw them my way. I may or may not be able to answer them, but I will definitely be interested in hearing them. So what we're going to talk about today is building secure images. And so part of the VMware portfolio of products that we, because we jointly develop PKS with Pivotal, we also contribute in our PKS stack Harbor. So one of the things we're going to be talking about today is Harbor's role. And how do we build a secure image? How do we build an image that has some provenance to it? We're sure that it's clean as a starting base, and then maybe some things that we look at as to how do we keep that running long term? Not only building the image, but how do we keep that safe in our environment? And so, if any of you guys were aware or not, Harbor, which is part of PKS, has actually been donated to the CNCF. So it's now an incubator project in the CNCF, and so it's feature-rich. We're going to show you guys an actual Concourse pipeline, which again is why we're getting the demo thing set up and Tom's spending the time that he is. We're going to show you guys an actual pipeline where we've written a Concourse custom resource type, which, hey, that's what's showing up right now, and kind of walk you guys through how we're at least building some of the DevSecOps chain of what you need to do in the actual image build process. And now we're going to slide over to slides. How you like that transition? And I'm going to hand over to my compatriot, Tom Kraus, because I'm just going to sit back here and I'm not going to say look pretty because I probably don't. But take it away, Tom.
Thanks. So your intro's covered? Oh, I have to use this, right?
Yes, Merlin Glynn, product manager for PKS.
So my name's Thomas Kraus. I work in the Cloud Native Apps business unit at VMware, focused exclusively on Kubernetes, PKS, and NSXT. So Merlin and I put this together about 7 months ago just to kind of demonstrate the application development lifecycle with containers and leverage some of the products in our portfolio, Kubernetes, Claire, Harbor, and Concourse, to show how that might fit to basically secure the process of developing and releasing applications within containers. So we have a half an hour. We're going to go relatively quick. It's not going to be a PKS or Kubernetes 101, unfortunately. But I just wanted to outline some of the solution components by themselves. We'll get into the actual solution, about 2 slides, which go into great detail about how we put it together, the different components, how they interact with each other. And then Merlin's going to spend about 5 to 10 minutes on a demo, depending on how well we do with the slideware. Merlin's also here to keep time, so he might be using a password to keep me going, because I tend to talk a lot.
Pineapple. If you hear me say pineapple, it means he's droning.
We did this at VMworld, and apparently I took 20 minutes on one slide explaining PKS, and I was chastised for that. So I'm going to try not to let that happen.
Mocked. Use the right word.
See, I beat you. I preemptively took his joke away because he was planning on using that later. So the goal here is to really optimize the software development process. There's a lot of buzzwords in the industry, but from a high-level perspective, we're trying to create code and automate how we not only deploy applications, but the entire life cycle of that application. So you can see here on the right, we have some various environments we're going to deploy to. Part of the enemy of that process and doing it effectively are snowflakes. And snowflakes tend to happen around infrastructure, and they tend to happen around the traditional way of doing things, where I'm going in and clickety-clicking things in a UI, or I'm updating config files on a Linux box, and I'm not telling anyone, and those never get tracked and never get version controlled and cause a lot of problems. And a lot of those problems are fairly obvious to you guys, I'm sure, but long-lived operating systems in either traditional physical hardware or virtual machines, infrastructure variability, so if I got test and prod, maybe I've got a specific type of data store or LUN in test and a different type in production. And then things like security policies. Those are going to vary from environment to environment. Application developers shouldn't necessarily have to care about those differences. They should be able to deploy their application, have it run in a resilient, efficient manner, and not worry about those various differences in those different environments. So the solution, obviously from a high level, established consistency and repeatability through modern software methodologies. So this is stuff that Pivotal's been preaching for quite a while. It's the way to do things. In my previous life, about a year ago, I spent about 2 years leading consultant teams for some very large customers. And we actually ran the DevOps teams that built and maintained the platforms like this. So we use source control. You couldn't make a commit to some automation scripts unless you had reference a Jira ticket in the commit message. You needed peer review for pull requests. So that was the actual platform team that was updating Ansible and Python, not just the application developers. So that's a trend I think we're going to see continue, especially in large enterprises, and something that was very effective for us. And you'll hear a lot of different ways to address this, right? There's probably 10 different ways you could skin this cat: configuration management, platform as a service. What we're going to focus on in this session is really container orchestration with Kubernetes, continuous integration, and infrastructure as code. And we'll get into kind of how we're going to establish some of that, or how we're going to achieve some of that. One of the kind of complications here is security. And we're going to get into how we enhance the security and kind of applied security best practices to this. But as you tend to automate these things and take humans out of the equation, one of the things that can sometimes suffer is security. And we'll talk about how we achieve that in this process. So if we go into the individual components, we'll start with Kubernetes. So application developers don't want to worry about infrastructure, like I said earlier. They don't want to worry about what type of storage is there, what's the capacity on the storage, how much memory is left in the cluster. They really don't care. So they want to deal with things like, how much memory and CPU does my application need? Do I need load balancing for a specific tier of my application? Do I need persistence? Do I need specific volumes or even storage characteristics? What type of security do I need? Now that's debatable from an application developer perspective. That's security posture for the application is probably a collaboration between the DevOps folks and the developers. But those are the types of things they should worry about. And that should all be abstracted from them. The underlying infrastructure stuff should be stuff that they don't need to worry about. Kubernetes does a great job of this, right? When I talk to new customers that are just starting this journey, the Kubernetes abstractions in and of themselves provide a phenomenal representation of an enterprise application, right? Enterprise applications aren't a single service or collection of services running on a VM or a physical node anymore. They're distributed, they're interconnected parts, they're proprietary, they're open source, mixed together. And the Kubernetes abstractions really facilitate running and maintaining these applications, right? Things like daemon sets, things like deployments, version control for deployments, how I want to react to an upgrade or a change in that deployment, rolling updates, services, right? I can describe all of that in a simple manifest, check it into source control, and easily apply that and track the changes to that deployment. And Kubernetes has a control plane which manages the process for me. I give Kubernetes my desired state. I want to run this deployment with 6 instances. I'd like it to be load balanced behind this service or this ingress. And Kubernetes will continue, the kube controllers will continue to maintain that desired state. Even if the cluster changes, right? Even if I lose 6 worker nodes and I said I needed 6 instances and 2 of my instances were running on those 6 nodes, Kubernetes babysits that and ensures that my desired state is met. It restarts and gets up to 6 instances. If I make a change to my deployment, it handles that in whatever way I told it to. So it's a real enterprise representation of an application. So where does PKS come in? So the talk, reference PKS, and if you think about Kubernetes as, like I said earlier, babysitting your application and ensuring that your application continues to run in the desired state, you can kind of think of PKS as maintaining Kubernetes to run in that desired state. So if you were to lose a couple worker nodes in your cluster, Kubernetes would react to that and restart the instances depending on how you deployed your application and make sure they were restarted on other instances. There's nothing that's going to restart the worker nodes or redeploy the worker nodes in Kubernetes natively. So that's something that PKS handles for you. Think of it as like the dial tone. It's providing almost the plumbing for your Kubernetes cluster. It's babysitting the state of the cluster, handling provisioning, handling seamless upgrades, handling node recovery, health checks, restarting a Kubernetes service that fails on a worker node. So it's a very, very powerful concept.
Yep. I'd asked earlier for people to raise their hands if they were PKS users or and/or customers. How about PaaS? Okay, so those of you guys that raise your hand on PaaS, you know that we have a staging process with a build back process for us to push applications. Kubernetes is not the case. So one of the things that you're going to see that we're talking about from a DevSecOps perspective is image building. You know, that's kind of what we're here to talk about, secure image building. One of the things PKS can actually play into this is API-driven creation of clusters for those build events. You know, ephemeral repavable platforms which Docker builds can occur because we can enable privileged exec mode and do that. That's exactly what we're going to do in our demo. But that's one of the things I want to call out is PKS itself is API-driven. And when you look at a DevSecOps approach where you may have to repave or rebuild even your build environment where applications and images are being built because you don't have that nice staging experience like you have with PaaS, that's kind of what we're talking about here. So it's just one of the things I want to bring up that you're going to kind of see that in the demo where we're running on a Kubernetes cluster provisioned by the PKS API that could just as easily be an ephemeral process itself in our build pipeline.
That's a good point. So we put a solution together which deploys to an existing PKS cluster or Kubernetes cluster that we provisioned with PKS. We could have just as easily told Concourse to spin up a new Kubernetes cluster on demand, and the entire cluster could have been our sandbox. We chose to use a namespace and network policy. We could have easily just provisioned clusters on demand. That's one of the things that PKS enables is very simple, 6 to 8 minutes. You have an entire Kubernetes cluster configured, ready for your image repository, ready for monitoring, ready for metrics collection, right out of the gate. So a couple different ways to skin the cat. Now I feel like I'm going too fast.
You feel like mean to cats. I don't know, but it does look like pineapple-colored walls. So
we need a code word for if I go too fast.
You're doing just fine.
All right. And my laptop just froze. Awesome. Okay.
So, once we get this back online, we're going to kind of fast, not to slide where you guys to death. The point we're trying to drive here is that if you want to build a good DevSecOps posture, so we're talking about DevSecOps, how do you build repeatable, portable, declarative-driven ways for you to make sure your applications are secure? That's kind of the end point we're driving to here. Wow, so PowerPoint's not responding. We're going to talk a little bit about, in fact, I'll even pass up some of these slides for you. I'll pineapple the slides.
Go for it.
Some of the things that we're going to be talking about and showing you in the actual demo today
Harbor's next.
is, so our registry endpoint, right? So if one of the key tenets of DevSecOps is to make sure that we're repeatable, we're declarative, but our image build process has some level of control of these are known good images. We know who the builder of the image is, and we know that the builder has at least some level of it's clean, some level of scanning applied against it that's auditable and traceable. So what we do with Harbor is we have a component called Claire, which was contributed to CNCF by CoreOS, and it's actually embedded in Harbor. In fact, we could just go straight to the demo if the slides are giving you too much grief. So what we're going to do is we're going to have Harbor as our registry endpoint, right? So this is the registry where a Docker image is being built. And Harbor's got two open source components that we're going to be leveraging. One of them called Notary, which is how we're going to get provenance of the image, which is how we're going to make sure that a trusted builder is actually building and updating that image. And the other thing that we're going to do is we're going to use Claire, which Claire is going to use the distribution's open source databases of known vulnerabilities against images built on their stack for us to be able to see what are the known exposures, what are the known CVEs in that image. Wow, that's an awesome demo.
We're restarting.
So what we're going to walk you guys through, we'll just go straight into the demo to show this. What we're guys going to walk you through is we've built a custom resource type for Concourse. So raise your hand if Concourse is something that you use in your environment. Wow, how about Jenkins? Okay, so wow, that thing speaks volumes. We're going to be showing Concourse, but this workflow could just as easily be provisioned through Jenkins. And we built a custom resource type, and that custom resource type, which we'll post out the GitHub repo for it, allows us, as we're building our image, we could put a couple of simple parameters in to build our image, to state that we want to sign the image and that we want to scan the image at build, and that we want the pipeline to alert us, to alert the DevOps lead when a build occurs that it's passing or it's exceeding a threshold of known CVE limits. He says as he's waiting for that. Pop-up. So on the notary side, why is that important? Is we want to make sure that in any good DevSecOps pattern, if you're publishing to a catalog, if you're publishing images that other development teams are going to be using to base their images off of internally, you want to make sure that you have some level of control over who is publishing that. So we use Notary uses something called TUF, the update framework. And the key thing that we're doing here in our pipeline is we're the update framework has a key exchange mechanism where there's a root key for a depot, and there's a key for each artifact inside of that depot that ensures that a known, only a Docker push can be accomplished after a Docker build has taken place by someone who has these two keys, by someone who has the root key for the depot, and depot is roughly equivalent to the registry endpoint. Oh wow, you got our slides back up.
I do.
Okay, so
for a couple minutes probably.
For a couple of minutes until you crash down. So the things I'm talking about, it's the slide thing? These Notary and Claire components in our Harbor implementation. So we're using Notary to sign, and I just mentioned the update framework, which I think, see if I dare to go into it. The update framework, it's actually an implementation of a key exchange. So if you look down here where you see the TUF, that's what the update framework is embedded in our registry. This is also how Docker does Docker Trusted Registry, right? It's the same mechanism or same footprint. We can actually have this private key exchange where we can have trusted authorities externally, or Harbor can be our own trusted authority. But the key point here is that as we look at integration, if you're going to build this type of automation in your pipeline, you need to handle these private keys. Because what happens is whenever you sign an image to start off with, you're telling your update framework, you're telling Notary, hey, every time someone wants to update this image tag, you got to have these keys. You got to have these credentials. Otherwise, we're not going to allow that to happen because that's the only way we can sign and know that it's being built by a trusted source. So what we're doing in our integration is we're actually storing that off in Vault. We've got a Concourse pipeline, and we built our custom resource type to leverage Vault to actually store that information externally. And we'll slip through these things. And PKS and NSXT, I think we're. Yeah, 10 minutes. Let's just get straight into demo. So we're gonna show you guys the pipeline that we built and why it's important. If you, yeah, fine. Why don't you go do this time?
So okay, thanks. So we borrowed this from Adrian Mouat on the new stack. So he took the application development within containers and the automation process and came up with some ideas for applying security best practices to this. So you can see here he has 6 kind of tenets, right? Image provenance, which Merlin just mentioned, is basically signing an image and proving that the person when you pull an image, proving that that image signature matches the person that pushed it. So you're basically saying, make sure no one tampered with my image, either en route or while it was in the registry, and it's the original image that was pushed by that identity, whose identity I know because he pushed it and the keys were generated and it was based on a certificate signature. Security scanning is the Claire scanning, open source, that's part of Harbor. We kind of skipped the Harbor slide, but Notary for image provenance and security scanning with Claire is all part of Harbor. That's built into the product, automatically configured, and integrated with your Kubernetes clusters when you deploy PKS. From an auditing perspective, we do that in PKS, and we also do it in Harbor. So we tell you who's updated a tag, who's pushed an image, who's pulled an image, and you get an audit log that's image specific in each repo. From an isolation and least privilege perspective, within PKS has this concept of plans, and the plans are used to actually pick a flavor for your Kubernetes clusters. Part of those plan settings, there's some security settings there to disable privilege mode for Docker containers, and basically you can enforce that as the platform administrator to be able to say, I'm not going to allow anyone to run containers in privilege mode. So therefore, they won't be able to access the local file system on the host, and they won't be able to do other things, run Docker and Docker. So it's a security enforcement that takes place. Access controls, what did we have for access controls?
Well, access controls are usually done within your image, like AppArmor and SE Linux, those type of implementations. So do you have some way in your image that protects unintended or unprivileged or privilege escalation happening inside your containers once they're running? So that's the concept of making sure that you have the right access controls in the image as you're building it. So this is a whole cyclical thing as you run through these. It's just part of good housekeeping as you build your images and run them. Because as I said before, in a Kubernetes environment, unless you're building it yourself or consuming it from a vendor, you don't have that nice staging process that you have in CF, where you can have this auditable, traceable build pack and controlled build packs that are used for your images. It's just a little, use the term Wild West. So you have to make sure you build some of these good processes and use some of these controls that we're going to show in the demo.
The other thing we do for access controls is leverage Kubernetes network policy. So we skip the PKS and NSXT pieces, but we can, as part of this deployment, this automated deployment that Concourse is driving, we can build a namespace and secure that namespace with what's known as a Kubernetes network policy, which will basically create the associated distributed firewall rules in NSXT automatically. And the life cycle of that Kubernetes object, which is network policy, is tied to the life cycle of those firewall rules. So if I update the policy, delete the namespace, my objects in NSXT are automatically taken care of for me. So it's a way to, that can be done at the pod level, that can be done at the namespace level. All right, I'll go to this mic. You take this one.
That's your cue.
Yeah, that's my cue.
Yeah. So we're going to go straight to demo just because we're running 5 minutes short with you guys.
Do you want me to go through this or no? Or you want to go right to demo?
Yeah, just go to the final slide, and I'll just walk through it real quick, just so we could show exactly what's going to happen. So on the previous visual, we're going to focus on steps 1 and 2, which is the provenance of the image and the scanning of the image. And so if you look at what's happening, the developer is going to be running a git commit. After the git commit is going to be run, we have a Concourse instance set up in our environment, which I might add the Concourse instance was deployed via Helm. So we just didn't want to deploy it in front of you guys because it takes like 4 or 5 minutes, and we're already strapped for time. But again, immutable, declarative, something we could just spin up in an ephemeral case just to get our Concourse instance up and run. So Concourse is going to detect the commit to the Git repo, and then it's going to pull, it's actually going to build our image, run a Docker build, where you see the Docker build and Docker tag, and push that image to our Harbor implementation. And you can see Harbor, it's got those 2 arrows for scanning and signing. We're kind of doing both in the same step, because whenever you're doing a Docker push, you enable trusted variable, and you set your, pass your keys to it, and you're saying, I am the guy that's been entitled in this depot to push updates to it. So we're making sure that provenance is happening and that Claire is also telling us there are any CVEs. And then the last step where you see that kubectl apply is that's after you've got the image pushed into your data store and it's signed and it's been set as clean, and we know that Harbor's allowing it to be pulled, that your community can then begin to leverage that image to build their other images or just to run those images if it has the base function that they need. So we're going to flip over to the demo and just actually show you guys what we're talking about here. Man, you didn't want to show the ShamWow slide? The only funny slide in there, and you didn't even want to show it.
You said we didn't have time. All right.
So he's going to flip over to a VNC session because this is running inside of my lab, and that's the only thing. I'm kind of averse to running RDP, and I'm an old dude. I mean, I'm wearing plaid and have gray hair, so I use a VNC still. So what you see in there is you actually see, there's a visual of Harbor. There's our registry, and you can see that we have this software depot, this registry endpoint of global catalog in SpringOne. So this is simulating like a real use case of someone is maintaining a set of curated images that we've scanned and controlled to make sure they're clean, so that our development community can begin to use those images to build other images on. And so what Tom's doing now is he's actually looking, so that we have this simple Go HTTP app, which again, it's a shame we don't have the time to show the visual because it was like Eddie Murphy and it looked kind of funny. But what he's doing is he's making a change. And if you notice the change here, like he's committing a change to the build, we're purposefully doing something stupid just so that we can show that the pipeline's going to catch us doing the stupid thing. So he's using a very old Alpine base build in his Docker build. And he's just going to run a git commit and push the image. You should use -am. I know I'm an old dude, but I can always do it in one step, and I'm doing it in 2.
Everybody here know what a base image is for application deployments on Docker? Okay.
Yeah, please raise your hand if we're saying stupid stuff, and we're just like, what are these guys talking about up here? Oh, that's awesome. Anyway, so Tom's going to go ahead and he's already committed, and he's pushing it up to our Git repo. Now what's going to happen is if we flip back to our Concourse instance,
our Concourse instance.
You can do Alt Tab there. We're going to see it, activate in the webhook in a minute. For those of you that aren't familiar with Concourse, it's a little visual-driven experience, and you're going to see it start to blink. It's like, hey, I've seen a commit there. And if you double-click into it, Tom, we can look at the runs, and we were practicing the demo for you guys just to make sure it was going to work. So you're going to see a lot of, you might have to scroll up on your thing. You see a lot of, red and green like a Christmas tree, because our previous runs always pass and fail because we're fixing and failing. But if you take a look at what's happening is, we're going ahead and pull, so you see where it says using Harbor Docker Concourse image version 001. This is our custom Concourse resource type. So this is the thing we've built that we're going to give you guys a GitHub repo to for those Concourse users that has this simple Docker experience, or excuse me, Harbor experience, where we're just telling Harbor the name of that repo image, like global catalog. We're telling it the location of the vault instance that has our tough keys to let us know that we can sign things and push it up to Notary. It's a really simple, not even 5 minutes user interface YAML file to set the pipeline, or easily driven in an automated manner so that we can create the pipeline and run it in an automated manner. So we see it, because Merlin has a really slow OLAB, just like he is, it is still pulling the image down.
One of the benefits, we skipped the Harbor content, but Harbor wraps the Claire is open source, Notary is open source. It wraps all of that with a common authentication and authorization endpoint and a reverse proxy. So you can access all of those tools, including the Docker V2 registry, across the same API endpoint. And it makes automation and CI a lot easier.
I do think we're going to get this done just under the wire.
It's amazing.
In fact, if you click on the green one, go ahead and click on run 7, and we'll show what a completed pass run, if you just click down on Harbor and we look at a past run. What we've done is in our pipeline, we've told it actually go up to the Harbor up above it. And that should get, click on that one. And if you scroll down, you can see where it's downloaded the image. And in our pass run, if you scroll down here to the bottom, you can see where it's checking if Claire scan is finished. And you can also see that the image has been signed and pushing a trusted metadata. Some of those lower lines, I could point them here. I know sometimes me just reading stuff we can see here that signing and pushing trusted metadata. That means our pipeline actually grabbed those keys from Vault, those trusted tough keys, to make sure that, hey, we gave the credentials to get that from Vault to make sure this pipeline is running in a trusted context for provenance. We also had Claire run to actually give us a CVE scan. And if you scroll down a little bit, Tom, we told it in our input into the pipeline that said, hey, we have a certain tolerance for CVEs. CVEs are known critical vulnerabilities. Sev1s. We'll take anything with less than 20 Sev1s, which is crazy and insane, but it worked for our demo. So we passed a JSON payload that said, hey, if anything that comes in under a certain amount of a certain Sev, we'll just report that out to the pipeline and go on and be along our merry way. But the important thing is all this happened at the same API endpoint, our Docker/Harbor registry endpoint, with Notary giving us our provenance and Claire giving us our security posture. Now, if we go back up, Tom, and look at our build that we just ran, where we changed something bad into it, and click back here, we can see that it's already failed. And if we go down and see failing why, we can see in the report that's coming out, it's saying, hey, this go round, I found 117 Sev1 CVEs because you've used an older Alpine image. Now, in our output, we wanted to make it a little sanitized and wiped for you, so we actually killed the array so that it wasn't showing what those CVEs are. But this is something we can pull from the Harbor endpoint to find out exactly what those CVEs are, what are the root issue of these CVEs, and what are the known fixes for them. And if you just flip back to the Harbor UI, we could just kind of end there.
It wasn't an Alpine image, it's a Trusty image. That's why it has
Trusty?
so many vulnerabilities.
Because we trust Trusty?
The Alpine image has fewer. That works.
So if you take a look there, this is that same image, tagged at latest. And we have a UX with Harbor as well that's pretty simple. We could take a look at that vulnerability report. And if you take a look at the vulnerability report after you refresh the page, it should actually show those failures. So 117 of them. And our image is signed. So this is something we can do from an API-driven standpoint. We can actually set up in the UI. And one of the other things that we could do with Harbor, which, again, we're focusing on steps 1 and 2 of that DevSecOps build, making sure the secure image is secure when it's built. We can even have Harbor prevent pulls if our CVEs are passing a certain posture level, so we can actually stop it from getting out in the wild. Now, one of the things, I'm gonna go ahead and stop and just see if there's any questions since we're kind of running over time, is does that get us all the way there? If you remember those 6 steps that Tom had put up there, in fact, if you want to bring back to the 6 steps, and then we could just see if there's any questions and wrap up. We've covered steps 1 and 2 in this bit of work. One of the interesting things, besides Tom's laptop going offline, is if you get down here to the end, it's all well and good to go ahead and make sure your images are secure when you're building them, and using some of the tools that we're talking about. But what happens when those images are run, those images are executed, and they drift over time? How do you detect this posture over time? And it's really interesting. Hopefully, the next time we talk to you guys about this, we're actually going to have some work from our VMware Application Defense product, which we're partnering with Aquasec, where we can use some of the open source components from Aquasec to actually help us report on the posture of these containers as they're running. So not only do we have a way that we can control what is good or what is clean and what is provenance when the image is created, but also what drifts from our security posture as things are running. And that's really one of the important things, or critical things, how to run this at scale. So that was a really messy, broken laptop rebooting, showing a quick demo thing. But yeah, we got through it. I'm not sure if you guys got anything out of it.
Thanks for coming at 5 o'clock. We really appreciate it. It's a weird hour, but we appreciate the time.
Yeah, well, these are some of the resources we use to build what we built. This is the Simple Go application we were using. This is that actual custom resource type for Harbor. Again, I know a lot of the hands popped up with Codbees. God, I know I'm getting old. Like when you start forgetting a word, Jenkins. This is definitely something we could do in a Jenkins framework, but we invested the time to put a custom resource type for Harbor together. And we think it's a really important thing to start talking about DevSecOps in the manner of image management, image curation, and making sure your image is secure. And we'd love to answer any questions if you guys have any. Okay.
Do you plan to use SpringOne instead of more? Because integrated with VMware and PKS very well.
So the question is, do we plan to use CredHub? So I will call out that what we've built isn't productized. It's just pushed out OSS. The reason we didn't jump straight to CredHub is because I'm the PKS PM, our implementation of CredHub for PKS is implemented for the control plane. It's not really exposed for data access, but yeah, we are planning to, as Tom and I kind of take the life cycle of this resource on, to extend it to use CredHub as well.
Thank you very much.
Thanks. Thanks, guys. Oh, is there another?